Hi, I'm Jim Lake. I'm a maker, a hobbyist, and an inventor. And I love my Tormach Series 3 mill. This machine has been great for me, and I've made all kinds of fascinating stuff with it. But like any complex piece of machinery, there's always a few things that you find annoying when you get to use the machine. And one of the few things that has been a problem for me as I've used this machine is the fact that there's no way to know the level of the coolant that remains in the coolant tank. We use this coolant really all the time. The coolant circulates through the system, it evaporates, it gets caught on various stuff, it's wasted, the coolant level drops. As the coolant level drops, it becomes more and more difficult for the pump to be sufficiently supplied during operations, and what can happen is that you can run right out of coolant during a project. But not so on my machine, because I developed my own coolant level system. This system is simple and straightforward, and it operates by having a float which is in the coolant tank, and the float moves the potentiometer as the float goes up and down with the level in the tank. The potentiometer sends a signal to a small microcontroller. The microcontroller formats that information and sends it up through this multi-conductor cable to this little plastic box with an LCD display inside, and it displays the current level in the tank. And I just filled this machine, so I'm currently showing me that I've got 95% coolant level. The controls on this device are simple and straightforward. The level is simply displayed on this LCD screen here, and there's a couple of LEDs, a green LED and a red LED. The green LED will slow flash when the unit is in operation, and that indicates that it is operating properly. There's a small hole here that accesses a control button that allows you to tell the machine that you want to recalibrate it. You just push it with a eraser of a pencil or something like that, and then you can recalibrate the machine simply by raising the float to its maximum level, punching the button, lowering the float to its minimum level, and punching the button again. That tells the machine what the range of values are for the float, and the microcontroller does the rest. The guts of this system is a 2" by 2" printed circuit board that contains the microcontroller, its firmware, some voltage conditioning equipment, and a mount for a linear potentiometer that's connected to a float and a rod. The PCB is mounted on the top of the coolant tank and is connected to a 5-volt DC wall adapter that plugs into the 115-volt AC power on the milling machine. The float rod projects through a slot in the top of the coolant tank. As the level in the coolant tank rises and falls, the float follows it, and the float rod turns the potentiometer proportionally to the change in level in the tank. The sender PCB's microcontroller monitors the wiper voltage of the potentiometer and converts that voltage into a percentage of the full travel of the float. That information is sent to the display unit, where it's presented on an LCD display. The only thing that the user has to do is calibrate the float. Well, there's no coolant in the tank at all, and we just set this system up, so you can't expect it to be accurate, and that's the purpose of the calibration routine. And we enter the calibration routine by punching this little button here 3 times. And when we do that, the LEDs will begin to flash, and the display says go ahead and push the button again. So push that button again, and it's telling us to go ahead and set the float at maximum. This is measuring the maximum amount of water that can be in the tank, and when we do that, to push the button. Now it says put the float at minimum, which I just let it drift down so the float just sits on the bottom of the tank, and we'll push the button one more time. Okay, it says the calibration is okay. Push the button one more time. Let the system reset, and it shows that the level in the tank is 0. And from this point on, the system will indicate the level in the tank, which corresponds to the position of the float, from 100% to 0%.